So, good evening, ladies and gentlemen. Can I confirm if you can hear me clearly, please? Someone?
Yes, we can hear you.
Okay. Thank you. Thank you very much. Thank you very much. We have a very important concept to learn today. And we are going to talk about what we call DHCP. This is a dynamic host configuration protocol. Dynamic host configuration protocol. This is the protocol that is in charge of leasing. People say it's assigning. When something is assigned, when you are assigned a job or you are assigned a duty, that duty belongs to you and you're not supposed to give it to someone else. When I assign you my car, or when I assign you a cloth or something like that, I actually give it to you because I take you an assignment which is entrusted only to you. But what DHCP does is that this protocol, which is a layer 2 protocol, what it does is that it leases IP addresses to end devices. It leases IP addresses to end devices. You and I know very well that every device connected to the internet must have an internet protocol address. All right. Everyone who wishes to participate within the internet must have an internet protocol address because that is a protocol upon which, every device rides. And so this evening, we want to talk about how does it exactly happen, because you see, there's the other side of DHCP, or the opposite of DHCP is just manually configuring these IP addresses, Yeah, and I could just, I'm going to demonstrate that. How do we do that? How do we manually assign an IP address? So to manually assign my computer an IP address, I'm going to right click on the network icon here. And then I go to open network and internet settings. Okay. And then I'm going to click, because I don't want to affect my network. I'm going to click Ethernet. I don't want to click Wi-Fi, because if I click Wi-Fi, I might change something which is going to disconnect my connectivity with you. Look at that. Did you get that? By interfering with the IP addressing scheme of my PC, I can actually lose connection with the people in this meeting. That's how serious IP is. And so I want to choose Ethernet. And once I choose Ethernet, I can go to change adapter options right here. Once I go to change adapter options, I can select Ethernet and then I right click on it and I select properties. Select properties. Once I select properties, then I need to select Internet Protocol version 4 here. All right. Of course, I hope you know that we also have Internet Protocol version 6. All of them are here. It means my PC is already ready for the transition. So I can double click on it, or I could just click on it once and then click properties. Don't click OK. And once I have that, I could take this to manual. And when I take it to manual, the first one says, sorry. The first one says, obtain IP address automatically. Ladies and gentlemen, this is what DHCP does. And by selecting that option, you're actually selecting DHCP. You are telling your PC to obtain IP addresses automatically. Through which protocol? Through the dynamic host configuration protocol. When you say use the following IP address, it means manually input your IP addresses here. So you're gonna manually put the IP address here, you put the subnet mask, and then you put the default gateway. And of course, including the DNS here and any second DNS you might have. So think of it this way. You are an IT technician or an IT admin at an organization with 500 computers. Those are 500 employees, and you are the IT person there. And so you don't have a DHCP server in your network, okay? And so the work you have to do is that you have to make sure that every day in the morning, every computer has an IP address. Okay. Of course, you put it, when you put it, it doesn't change. It remains there manually. But when you change your network, let's say you've been working with this ISP, and then you're gonna have to change your network. So when you change your network, it means you get a new ISP. When you get a new ISP and you're using the manual configuration, and you're told that tomorrow is Wednesday, and by tomorrow, 8 a.m. in the morning, every one of the 500 desktop computers and printers, they need to have been manually configured with IP addresses. Now, that's a very big deal for you, because if for every computer, you must put at least 4 addresses, which is the IP address, subnet mask, default gateway, and the DNS. So about 4 addresses. And so by the time you power every computer, power it on, it takes maybe like about 5 minutes or less, maybe 3 or 4 to power on. Then you navigate through until you reach here for each computer, which means you are taking about 10 minutes to configure an IP address on one PC, and you have 500 of them. So which means that if you have 500 computers and you have 10 minutes per computer, that means you're going to multiply 500 times 10, which is actually 5,000. You take this 5,000 minutes, you divide by 60 to get hours. When you divide by 60, you get 83 hours. 83 hours. It means what time do you go to work? So that by 8 o'clock tomorrow, because from now until tomorrow is just about like 12 hours, maybe 14 or 15 hours. And you're getting 83 hours to configure all those computers. It's impossible. What if you have come to our class, Cisco class, and you have actually been taught about DHCP, and you've said, instead of me configuring all the 500 computers, I'm going to choose one of the Cisco routers, and I'm going to configure it to become a DHCP server, so that tomorrow when it is 8 o'clock, every one of the 500 computers will acquire an IP address automatically from our DHCP server configured on the Cisco router. That's how DHCP, that's how knowing how to configure DHCP could save you. This is how we manually do it. Why do we discourage it? Of course, there are circumstances when it is also required, the manual configuration. We discourage it because of normal human nature mistakes. You can make a mistake by configuring a wrong IP when the brain is tired. You can configure the same IP to 2 different PCs. Okay. You can configure just mistakes, wrong subnet mask, wrong DHCP, DNS, and that will be the genesis of your problems. And now, to save yourself from these problems, one of the objectives that we are going to learn today, as can be seen on our as can be seen on these particular slides, is that we're going to explain how DHCP operates in a small business network. We're going to configure a router as a DHCP server, very important. We're going to configure a router as a DHCP client. What do you mean by that? It means even a router can acquire an IP address using DHCP, and that's going to happen today. And the last thing, which is not stated there, but we're going to talk about it, is we will configure how to configure a router as a relay agent. What the hell is that? Now, this is the topology that we're going to be using, and I want us to pay attention to this one here, because it is very, very important for us to do so. It is very, very important for us to do so. It is important for us to do so. Now, In this topology, there's a couple of things to note here. Okay. Am I still audible? Someone, please? Am I?
Yes, you are.
All right, thank you. So this topology has so many faces here. I want you guys to look at it very keenly, because you will also meet one like this very soon. Now, so the topology here has a couple of networks here. So we can see that on router R2, we have this network here. This is network 192.168.20.0. We have this network between R2 and R1. This is another network. It's not labeled, but it is a network. We have another one between R2 and R3. All right. And then between R1, there's a LAN on R1. Network 10.0 is here, and network 30.0 is right here. We have a remote network connecting our router R2 to the remote network in the cloud, the internet. Network 200.2.24 is there. Then here we have two Cisco servers here. And there's a, that is a Cisco server, and there's a public site. This is a web server right here. So let me give you the scenario of how things are gonna work here. So the thing is, let me just remove the colorings there. So the thing is this, we are going to configure, and these are some of the objectives that we're going to achieve at the end of this lesson here, or lecture here. So router R2 is actually going to be our DHCP server. That's point number one. So we're gonna configure router R2 to be the DHCP server of two networks. Router R2 is going to be the DHCP server of network 10.0 and network 30.0, point number one, which means you're going to configure two DHCP servers within our router R2. We call them pools, two DHCP pools, one for this LAN and one for this LAN. Then router R2 is going to acquire a public IP address from the internet, from the DHCP server found on the internet, automatically. So the interface of this router R2 connecting to the internet will acquire an IP address automatically from the internet, and I will show you how to do that. And then something funny will happen. Of course, you can see we have our DNS servers here. Something funny is that a router configured as a DHCP server can only provide IP addresses freely to devices that are on the same network as that particular router, which is the server. Now, funnily enough, the two networks that are supposed to acquire IP addresses from the server are actually in a different network. They are one hop away. Like, we have to go through another router to reach them, which means they must go through the R2, must go through R2 to provide IP addresses to the any PC in this network. And so is the LAN on R3, okay? So wherever the DHCP server is in a different network with the host devices that need IP addresses, the router that falls in between the server and the IP addresses, those two routers, they have to be configured to become middlemen. That is a layman language. They must be configured to become middlemen, which means they're going to be brokers. They're going to broker communication between the guys that need DHCP services and where the DHCP server is. All right. And so just like when we are running a relay race, where you come with your button and you give to the next person the button, and they continue running and they give to the next person the button. And so that's what's gonna happen here. This router is going to become what is called a relay agent. So it's going to relay messages from the PCs here to the server, from the server back to the PC. So relay agent, relay agent. So this is how, this is the objective we need to achieve at the end of this class today. Everyone needs to know how do we do that. So let's go back to our PowerPoints and let's see how things are going to be here. All right. So, let me just do this. So let's start by learning about some concepts here, some of which I have already talked to you guys about. DHCP, like we said, is Dynamic Host Configuration Protocol. And today we are talking about the version 4 of DHCP, all right? Version 4 of DHCP is for IP version 4 addresses, all right? And so it's a way of, the DHCP server or this DHCP protocol, it leases IP information, including IP address, subnet mask, default gateway, DNS, domain names, and all that, right? And so it's a time-saving tool for any network administrator, for which all of us are training to be. Now, any kind of a dedicated DHCP server must be very scalable and very easy to manage, okay? Mostly in our networks, small networks, we always just use our wireless router is always the one providing our DHCP services. And let me move it closer. If you are that person who creates hotspots on your phone for other gadgets, like your laptop, or even your other friends' mobile phones to connect to your network, I need you to know that by creating a hotspot on your router, on your mobile phone, you actually make your phone to act as a router. And when your phone acts as a router, it also acts as a DHCP server to those devices connected to it. And that is how funny it gets, all right? And so DHCP, like we said, automatically assigns IP addresses to a pool of addresses for some period. That's why we call it leasing, because that address is always provided or assigned only for a specific period of time. By default, that time is always 24 hours, but that time can be changed, okay? That time can always be changed. Now, so DHCP operates on a client server mode in such a manner that the PCs that need IP addresses are called DHCP clients, and the server that provides the addresses is called a DHCP server. It's called a DHCP server, okay? So, whenever the machine is powered on, the first thing it does, it must acquire an IP address. It must check the closest DHCP server to be able to provide that address. Now, since I said that address is always provided for the 24 hours, the first 24 hours by default, it doesn't mean your computer will stop accessing the internet after 24 hours. The DHCP as a protocol between the client and the server, they have a way of renewing that list for another 24 hours, and it will keep on going on and on and on. And now, I don't know whether this is something I have told you guys before, that every time a computer is powered on, okay? Every time a computer is powered on, the computer needs to look for the first DHCP server in the network. And like we said, that the DHCP process takes place within the first 15 seconds. And so the PCs, by default, they don't just, they don't just get the DHCP server and then immediately they get the IP address. There's a procedure that must be followed, and DHCP has actually set up that procedure. What is the procedure? Your computer or the end device and the DHCP server must exchange a couple of messages. There are actually 4. So for IPv4, your PC will start by sending a message called the DHCP discover message. So your PC will send the first message called DHCP discover message, which basically says, I would like to request for some addressing information. It tells that to the server. Then the server replies back to the client saying, I'm a DHCP server, and here is an address offer. So the message that the server sends to the client is called DHCP offer message. DHCP offer message. The offer actually carries everything that the PC needs. Okay? The offer carries everything that the PC needs. You know, like when you tell someone who is selling some materials, or they're selling clothes or shoes or something like that, and you tell them, excuse me, can I get shoe number 20 and or shoe number 14 or something like that? They're gonna bring for you several types of shoe number 14. All right. And then maybe 12 or maybe 7 or 8. And then it does not mean that when they give them to you, you pick them immediately. You know, you're gonna make your choices and you're gonna make a decision on which one exactly you're going to pick. So the server responds to the DHCP offer, which the offer actually carries the IP address, subnet mask, DNS, default gateway, domain name, and all that. Then the client receives that message, DHCP offer, and the client responds back to the server with a message called DHCP request. The request is actually the client telling the server that I have accepted the addressing offer, so may I use it? And so a DHCP request message is sent to the server, and the server sends the final message, which is called DHCP ACK. DHCP ACK, which basically means DHCP acknowledgement. So the server tells the client that your acceptance has been acknowledged, and you go on and use that addressing information for the next 24 hours or for the next, the time upon which it has been set. And so it's important to note that there are 4 messages, 2 from the client and 2 from the server. But it is important to note at this point that the messages from the client are always all broadcast messages. They can go to any server. But messages from the server to the client are always unicast messages. So I hope you guys get to understand that really well. And so it is important, I'd already given you a mnemonic to master these words. So from discover, offer, request, and acknowledge, and we gave it the name Dora. Dora is a lady's name, but Dora, where D means discover and O means offer. Request means, the R, and then of course the acknowledgements is the A. So Dora is a very good mnemonym for mastering that sequence over there. What if the PC has used that address for the next 24 hours, for the last 24 hours, and they need to renew it? They need to renew that particular lease. Very simple. The PC is gonna send one message, just a DHCP request. Okay. The PC is gonna send a DHCP request message, which is unicast to the server, and the server will respond to the unicast message, DHCP acknowledgement. Okay. So DHCP request and DHCP acknowledgement, or DHCP ACK, those ones are used to renew the lease. They used to renew the DHCP lease. All right. Having said that, we want to look at, basically configurations, because we have already seen how DHCP actually works. So let's now look at how do we configure this protocol here. How do we configure this protocol? So like I said, if R1 is supposed to be our DHCP server, R1 can provide IP addresses to this network here, and R1 can still provide addresses to this network. And so some of the parameters that are normally configured are as follows. You must tell the DHCP server what is the network address, okay? What is the default gateway? And the command is default-router. What is the DNS server? That is the DNS address. What's the domain name? You could tell it how much lease time. You can change it from 24 hours, and you can make it to a lease time of even infinite, means it will never stop being used. Or you could say it days, how many hours or minutes. I mean, it all depends on you. Or you could even send the net BIOS, the name server, for those who use some of those Windows servers there. So these are some of the properties that are always configured, and you could see an example here. We want to configure this router R1 to be a DHCP server. So the first thing we do is very important, and I don't know how I didn't mention this, but it's good time that I'm mentioning it right now. Let me give you another small parable here. So you and your friend, male or female, you and your friend, you have decided, that it is Easter is coming, and you want to visit an orphanage where teenagers are. And these teenagers, they will like to use mobile phones because the orphanage has some Wi-Fi network, but they don't have money to buy the mobile phone. And the orphanage manager does not have enough money to buy a mobile phone for each of them. And so they are in distress. So what happens? You and your friend, you decide you want to go and give back to the community. And so you decide we're going to buy mobile phones. Let's say we have 200. You have 200 teenagers in the orphanage, but your budget can only accommodate 150 mobile phones. Obviously, 50 are going to miss, but they can share. I mean, if that is what is possible there. And so you take a suitcase, you buy the 50 mobile phones, sorry, 150, and you put them in the suitcase, but you forget one thing. You forget, and you and your friend, your two phones, you also forget and put them inside the suitcase. And when you get to the orphanage, you open the suitcase flat on a table, sort of, and you open it, and the teenagers at the orphanage, they're not very organized. So what do? Since the mobile phones, like, wow, one make all of them, they come to scramble for them. And so it is survival for the fittest, because remember, there are 200 and you only bought 150. And the other two are yours, so they are 152. So they come and scramble for them. And before you know it, in 1 minute, 60 seconds, which is more, these guys have already picked, everyone now is having their mobile phone and they're struggling to connect it to the Wi-Fi. Now, it's upon when they finish that you realize that, oh, we had also put our 2 mobile phones there. What's going to happen? How do you start telling the teenagers that, you know what, the mobile phone that you took was actually mine. I had actually forgotten. They're not going to understand that. I mean, you're going to surprise. You'll be sympathizing with them. And so the best you could do is probably just to leave it to them. You could take your SIM card or something like that. And so the question is, what could you have done before you called the teenagers to do what? To pick the mobile phones. You could have thought very fast, remove your 2 mobile phones, and then let them to pick up the 150 that were there. But because you didn't do that, you're gonna have to pay the consequences. Now, I want you to turn that small parable into this way. When we are configuring DHCP, you guys realize when you did subnetting, we were able to subnet and we were able to get the ranges of different IP addresses. Okay, so there was a first range. Every range had a network address and broadcast address. It had first usable, second usable, all the way to the last usable. All right, and what happens is that it was important that we were able to produce different number of IP addresses for each and every network. And so if you're going to configure DHCP, the moment you configure, you tell the DHCP server that this is going to be the network address. You know what the DHCP server does? the DHCP server picks from the first usable up to the last usable and places them in the pool. And like I told you, by the way, not all devices require IP addresses automatically. Think about your switches. They need management IP addresses. Think about your servers. They need management IP addresses. Think about your routers, your firewalls. Eh? They need management IP addresses which must be configured manually. Why? Because you don't want the address to change, because the IP address that your PC acquires today is not exactly the one it will acquire tomorrow because of DHCP. Okay? And so the thing is, you want to separate some of those IP addresses that you might want to assign to devices manually. You want to remove them from the pool. You get my point. You want to remove them from the pool before you create the pool. So you want to remove your 2 mobile phones from the pool of the suitcase before you offer the pool to the teenager. That's exactly what I'm saying. So the first thing you do when configuring DHCP is to exclude addresses that you might want to use manually. And so the commands are here. Let me just all right. So you want to say IP DHCP excluded hyphen address. Very important. IP DHCP excluded hyphen address, and you can put a range. So this is 192.168.10.1 space 192.168.10.9. So from 10.1 to 10.9, that is the first 9 addresses have been excluded from the pool. Then we have also excluded the last usable address here. IP DHCP excluded address 192.168.10.254. You could actually exclude them with the same command one by one, but if there are ones you can put in a range, please try to use the command range, the command here, by just using the first, put a space, and then the last, and that will put the first 9 address. And then of course, we have also secluded the last address there. These ones are for manual configurations. Upon doing that, then now you can now begin configuring DHCP. And to configure DHCP, the first thing that you do is to create the pool without anything. You just need to say IP DHCP pool, IP DHCP pool, all right? And then what follows after the pool is a name. This is the name of my pool. And you can make it to describe your department, your network, your company, whatever it is you want it to be. And the name of the pool given here is LAN-pool-1. The name should not have any spaces. Instead of spaces, you can use underscore or hyphen. Preferably, the name should be in capital letters, but it's not a must. We put it in capital letters for easy visibility. You can separate the name from the commands. The moment you just say IP DHCP pool, look at how the prompt changes. The prompt is going to change to DHCP-config. This is a DHCP configuration. This is a DHCP configuration prompt there. So once you create the pool, then now you populate the pool. Tell the pool what components do you want to be in the pool. You can now tell the pool which network. You say command is network 192.168.10.0, and this is the subnet mask. The server or the router is very clever. The router is going to be aware that even though I've been given this pool of 10.0 network, 1.9 is not here, and 10.1 to 10.9 are not present here, and the last one 10.254 is also here because it was already configured. So the router will never assign any address from this pool. It will start assigning from .10 to .11, 12, all the way. Now, the next, after telling the router what is the network address and the subnet mask, tell it what is the default gateway. The command is default-router. Default-router. Look at the address of the router, 10.1. It's among those that had been excluded from the pool. If we didn't exclude, 10.1 that we have said is the default gateway for the router could also be assigned to another end device. And those are mistakes you want to avoid. Then we can configure the DNS server, which is can be in your own network or can be away from your network. Again, this is a device that must be given a static address, which does not change. And so you say DNS-server, and you put the IP address of the server here. These addresses are put without subnet mask. This DNS and default gateway. So default-router, DNS server. You could put a domain name, say domain-name, maybe ku.ac.ke or whatever it is, cisco.com or example.com. Very important. Once you do this, you're good to go. Everything will go as expected. This was the server here. The server can be in the same network as the server, a DHCP server, or the DNS can be always in a different network. Very important command. Show running config, and you pipe it to or you filter it to only reveal DHCP part of the running configuration, saying section DHCP. Or you could say show IP DHCP binding, show IP DHCP binding, or you could say show IP DHCP server statistics. Now, when you say show IP DHCP binding means I need you to note that every time any DHCP server assigns an IP address to an end device, that DHCP server records the MAC address of that device plus the IP address it has given out. So it actually binds the IP address to a MAC address. That's why when you look at show IP DHCP binding, you look at which IP address has been bound to which MAC address. And that's how you could do things like blacklisting within your wireless router, so that you could blacklist MAC addresses connecting to your network illegally. Just blacklist them. They'll be connected to the network, but they'll never access the internet. Very important. The statistics, of course, will show you which addresses have been given out and which ones are remaining. All right, so this some of the show commands being given there. You can see here, this IP address 10.10 has been bound to this MAC address here that you can see here, and it was on this date and time. Okay. For statistics, basically, of course, we'll give you the statistics that we were talking about. And, who have been bound here so far, we only have one pool. The rest are zeros because our configuration is not very comprehensive. And you can see there are 4 messages are actually there. Now, you could still check on your PC and check if your PC has acquired an IP address. For example, you could see here when you say ipconfig/all on the command prompt, you could see that the DNS is actually example.com here. The IP address that was assigned is 192.168.10.10, and the subnet mask is 255.555.0/24. When was this list obtained? It was obtained on Saturday, September 14th, 2019 at that time, 8:42 a.m. When will it expire? And the expiry time is here. What is the default gateway IP address is here. The DHCP server's IP address is here. The DNS server is here. All this is information you can see from your own PC. Even as we speak, you could just do ipconfig space/all. And that is something that will be sorted. Now, you can always disable. You can always disable and enable back the DHCP service in the router. If you don't want to use the service in the router, you can put it off and you just need to say no service DHCP. And to bring it back, you say service DHCP. It will always just start working automatically. This is important, guys. I had, of course, talked about it, and we're going to configure it. Relay agent. Like I told you, relay agent within DHCP server is very important. Not just with DHCP, relay agent, they're used to relay so many things. So a relay agent is used when a DHCP server is found on a different network from the client devices. And so a router must work as a relay point, or we call it a relay agent, to relay information from the client to the server and from the server back to the client. And so that's what they are trying to tell here, to say here. And so to configure relay agent, normally it's very simple. I need you to note something here. Let me just zoom this in. I need you to note something here, very important. Every time you see me zoom like this, I want to emphasize on something. So let's say the server is here. This is our DHCP server. The router here, R1. The router R1 is the intermediary between the server and the PC1, which is looking for a DHCP server. So of course, PC1 will be sending the DORA messages, DHCP discover, DHCP offer, DHCP request, DHCP acknowledgement. So the DORA messages will go to R1, R1 relay them to the server. Server to R1, R1 relay to the server. Until all the messages have been sent. Now, how do you configure R1 to act as a relay agent? Point number one to note. Point number one is this. You must configure the relay agent on the interface of the router facing the client. Okay? If you are keen, we have interface G000 here is the interface of this router facing where the client is. So the configuration is always done on the interface facing the client. And you must state the IP address of the server, which is on a different network. And so the command, you'll get into this interface, maybe interface G000, and you say IP helper hyphen address, IP helper hyphen address, and then you put 192.168.11.11.6. Let me just show you that here. It's very simple. So interface G000, IP helper hyphen address, and you put only the IP 192.168.11.6 of that interface. And you could say no shutdown if the interface is down. And that's how we configure a device as a helper or as a relay agent. Configure it with a helper address, IP helper hyphen address, and put the address of the server. You put the address of the server. And now, you will say show IP interface G00. Of course, you'll see the helper address is actually there. Now, the relay agent can relay so many things apart from DHCP. It can relay time. We'll talk about a time protocol called NTP, which is network time protocol. When you configure relay agent, it can relay PACAX. This is for AAA, authentication, authorization, and accounting. It can still relay DNS settings. If the DNS server is found on a different network than your own network, then it will do that. Of course, DHCP we've talked about there, TFTP, NetBIOS, and all that. We will configure DHCP as a relay agent, as a server, and as a client. We're gonna obviously do that. The last thing I want us to check is configure DHCP as a client. How can you make the router to receive an IP address as any other PC? And it's very simple, very, very simple. Let's say that this is our home router and we need it to receive an IP address from the DHCP server found in the ISP network. Simple. We get to interface G001 and you say IP address. You know the way you assign an IP address on an interface? You say IP address 192.168.10.0. This time around, you say IP address DHCP. Look at how simple that is. IP address DHCP, and you say no shutdown. You are done. You are done. That should be very simple. That should be very, very simple. Yeah, and that is it. Interface G001, IP address DHCP, no shutdown, and you're done. You don't have to worry about anything. Of course, I know that in our routers at home, we use wireless routers, and the wireless router normally obtains its IP information, DHCP, or it assigns our end devices with automatic IP addressing, and that means DHCP is always turned on. So what I'll need you to do, if you have a wireless network at home, please talk to the provider to give you access to your router. They're gonna give you an IP address and some passwords there. When you get in, please, you need to look for where is this, the network setup. And you'll see all these things I'm actually talking about. Okay. And so now at this point in time, I want us to do some serious work here. Let's do some serious work. Let's do some configurations here so that we are on the same page here. So like I said, I'm going to give you something almost similar to this and see if you can be able to crack it up. So the first thing that we need to do is we need to, let me see. Yeah, according to the instructions here, we need to configure R2 to exclude the first 10 addresses from R1 LAN. Let me just go through the instructions briefly so that we are clear of what we are doing. So we are told on the scenario that a dedicated DHCP server is scalable and relatively easy to manage, but it can be costly to have one at every location in a network. However, a Cisco router can be configured to provide DHCP services without the need of a dedicated server. And as the network technician for your company, you have been assigned the task of configuring Cisco router as a DHCP server. You're also required to configure the edge router as a DHCP client so that it receives an IP address from the ISP network. So we're going to configure router as a server. And the first thing we do is to exclude addresses. And we're told addresses that have been statically assigned to a device, to devices in the network. Addresses that have been statically assigned to devices in the network that will use DHCP must be excluded from the DHCP pools. This avoids errors associated with duplicate IP addresses. In this case, the IP addresses of the R1 and R3 LAN interfaces must be excluded from the DHCP or from DHCP. In addition, 9 other addresses are excluded for static assignment to other devices such as servers and device management interfaces like switches and routers themselves. And so we are told to configure R2 to exclude the first 10 addresses from R1 LAN. Then we'll also configure R2 to exclude the first 10 addresses from R3 LAN. I wanted to see that. So we're going to configure R2, which is going to be our server, to exclude the first 10 addresses from R1 LAN and also from R2 LAN. How do you do that? Let's see that. So to do that, let me just do this. I want you guys to see everything I'm doing. And that's why I want to it's not going to be possible. So that's okay. I'll just put it here. And you can see there's something is already happening here. Our network is using EIGRP. How do you know that? You can say show IP route DHCP, not DHCP, EIGRP. You can see some routes here. Yeah, 2 routes here have been learned through EIGRP. You see that by letter D here. We'll talk about routing and you see that by the 90 here. Don't worry, we'll talk about this later on. Huh? Yeah. So simple. Let's do what we have to do here. So we are told in R2, we need to exclude the first n addresses of R1 LAN. So what I do is that I need to go to the global config mode, I say conf t, and I need to say IP DHCP excluded hyphen address. IP DHCP excluded hyphen address, and I say 192.168.10.0. Sorry, not .0.1. IP DHCP excluded hyphen address. I want to exclude the first 10. So 10.1 space 192.168.10.10. Okay, and you press enter. Let's exclude the 10 from the other layer 3 LAN here, 30.0 network. So we would say IP DHCP excluded hyphen address 192.168.30.1 space 192.168.30.10. So 30.1 to 30.10, that is the first 10 addresses. So we have excluded the pools very nicely. And we need to go to the next instructions now. You can see we already have 9 marks there. The next instruction says now that we need to create pools on R2 for R1 LAN. We need to create pools on R2 for the R1 LAN, the first pool. And we are told the name of the pool is R1-LAN, capital letters, R1-LAN. So we say here, IP DHCP pool, all right? And then we put the name of the pool. The name of the pool is R1-LAN, R1-LAN, and we press enter. And then we are told to include the following network address, default gateway, and the IP addresses of the DNS server. So for the network address, we say network, and we say 192. Remember, this is for R1 LAN. 168.10.0 is the network address. The subnet mask is 255.255.255.0. Okay. And we press enter. What did I say here? Oh, I know where the problem is. There's something missing here. Dot. And what I would like to do is that I would like to expand this so that you can see everything. Yeah, so that is 192.168.10.0, and the subnet mask is there. Press enter. Default -router should always be the first usable address, but not obviously. Default -router, default router is 192.168.10.1. Remember, we're still dealing with the first network. We've not gone to the second one. So 10.1 is the default gateway. Enter. Then you say DNS-server, and we are given the DNS server as 192.168.20.254. Someone can be asking me, where is this DNS server? This DNS server is actually here, but its address is been given for us on the table here. 192.168.20.254. That's where we get it from. Okay. Once you do that, on R2, a DNS server, you need to press enter. All right. Now those are the few instructions we've been given there. And then we need to now do the same thing for R3 LAN. You need to exit here. You need to start again. You say IP DHCP pool for R3 LAN. The name is R3-LAN. R3-LAN. That is the name of the pool. And I think you can create up to so many pools here. I don't know how many pools it creates. Anyway, so R3 LAN, enter. We give it its network. Say network. It was 192.168.30.0. 255.255.255.0. Okay. That is the subnet mask. And this one will also know that the first 10 from 30.1 to 30.10 will not be available. The assignment will start from 30.11, and we shall see. We press enter and we say default -router 192, the first usable, to 168.30.1 DNS. Say DNS hyphen server. It was 190, the same one, 191.68.20.254. Okay, press enter and you're good to go. Now I want us to test something. Ladies and gentlemen, until this time, let's go to the PC1 and try to see if it can acquire an IP address through DHCP. Go to desktop, then click IP configuration, and we go to this point here. This is static. Let me zoom that in. This part here is static. This is DHCP. Okay. On a real device, it was written obtain IP address automatically. Okay. So you're gonna select DHCP here and see what's gonna happen. And so let me do so right now. And let's see what happens in a few seconds. Requesting IP address. Look at this. This is an equation that will come to your exam, my friends. It is saying DHCP failed. APIPA is being used. I told you guys about APIPA, automatic private IP addressing. This is the address that the PC assigns itself if it cannot find a DHCP server in the network. And the address begins with 169. This is very, very important. 169.254. So if you ever check any PC that is not connecting to the network, one of the points you need to check is the command prompt. Go and check what is the IP address that it has been assigned. If you ever see 2169, just know that the problem with that computer of your client is that it will not locate the DHCP server to acquire an IP address. And so what you see here is that DHCP has failed. No default gateway, no DNS. Subnet mask is /16, which is not appropriate. We didn't configure that. So what we need to do, it means we have not done something. Just a minute. I actually want to take it back to static. I don't want to leave it there. Yeah, because I'm it. Let me look at PC2. Maybe PC2 is lucky. Something here. If I change it to acquire through DHCP, serious problem. DHCP failed. Look at that. DHCP failed. We don't want to see this. And so that rings a bell in our minds that there's something more that we have not done. What we have not done is that we have not told these two routers to act as relay agents. The network is very well, the server is working perfectly well, but we haven't configured these two routers to act as relay agents. And that's exactly what we're going to do. But it requires some little bit of keenness here. You're going to be keen for you to do that. One, we know that we are going to configure the helper address on the interface of R1 facing the clients. But we're going to put the IP address of the server. Now the server is having so many IP addresses. Because every of these four interfaces, each of these four interfaces here. So the server, which is R2, has four interfaces. The one going to S2, one coming to R1, one going to the internet, and one going to R3. We need to choose one of them to act as the server IP address. And so the server IP address will have to be the interface facing this router here. And so we need to know that interface. You need to know the interface of the R2 facing R1. Now that interface can be known from our table. Since this is a network that is being shared between R1 and R2, we could go to our table. We could go to a table, and between R1 and R2, we'll check which IP addresses are on the same network. Look at this, is 192.168.10.1. This is 10.1.1.0. Which one of them are in the same network? This is 192.168.10.0. This is 20.1. That is wrong. G01 will be assigned by DHCP, but we do have this 10.1.1.2, and we have 10.1.1.1. See that? Which means that this is what it means. It means that 10.1.1.1, which is for R1, is actually the IP address of this interface, and 10.1.1.2 is the IP address on the server, on the R2. It's important that you note that. Okay, because we are looking for it. We are looking for the IP address of this interface facing or on the same network as R1. Once you get it, we already gotten it is 10.1.1.2. Then we need to know this interface here, which is the only gigabit Ethernet interface. So going to R1, if you go to R1, I want you to know that the red one is a serial link. The black one is a copper link, and that is a LAN. And in the LAN, normally we have gigabit Ethernet interfaces. So looking at R1, R1 has only two interfaces, G00 and S00. S is the serial, the red one. G0 is the black one, and that's the LAN. You can see the address that is there. But for us, we just need to know it is interface G00, and you need to know it is the IP address 10.1.1.2. And we're gonna do the same. Okay, we're gonna do the same. Let's configure the first one first, then we come to that other one. So I know that I need to go to R1 here. I need to say enable. I need to say configure terminal. And then I need to get into that interface and say interface G0/0. Enter. And I need to say IP helper -address. Then I say 10.1.1.2. And it's done. And I need to look at how to identify the same thing. If you didn't get the first one, can you look at how I do the second one? I'm gonna zoom it again, sorry. I want you to check at what I'm gonna do for R2 and R3. So R2 and R3 are sharing the same network here, which is their interfaces must be on the same network. Okay. Now, we need to check the interface of R2, which is sharing a network with that of R3. And then we also need to check the interface of R3 on a LAN network, on the black network. So checking at the table here very well. So on this one, looking at router 2 and router 3. Router 3 has only 192.168.30.0 and 10.2.2.1. R2 is having 10.2.2.2 here. Here we go. 10.2.2.2 and 10.2.2.1. One is the first usable, one is the second usable, which means we are looking for the one on R2, which is 10.2.2.2. That's the IP address we are looking for. And the interface we are looking for is G00 of R3. So what we are doing here is 10.2.2.2 is the interface of this router here. And the 10.2.2.1 must be for this interface of R3. And we are looking at G00 on this particular interface. And that's it. That's it. So we just need to go to R3 You go to R3, you say enable, configure terminal, and you say interface G0/0, enter, IP, helper -address 10.2.2.2, okay, and press enter. And now, ladies and gentlemen, let's go back to the PCs and see if they can now acquire an IP address. Go to IP configuration on the desktop and now select DHCP. Let's look at that. Oh, look at what happened here. DHCP is now successful and they have acquired 10.11. You can see the first one, because we reserved the first 10, it begins at 11. Subnet mask is checked, default gateway checked, DNS checked. Wow, that's very interesting. And can we move from here and go to the command prompt? And it will say IP config space all. And look at that. Look at this. Okay. You can see some more details here. 10.11 has been assigned. Subnet mask is here. Default gateway is 10.1. DNS servers. You can see the DNS server was 10.1.1.2. DHCP DNS server. So this is the first one was DHCP. This is DNS server is right here. Okay. And you're looking at the first Ethernet connection. This is the LAN. Okay. And they are, like Bluetooth connections and all that. Those were not reserved. So this guy has successfully received its IP. We go to PC2 and we enable DHCP here. And let's see if it's going to acquire one of its own. Boom. You can see that it has also acquired an IP address 30.11.255.0 subnet mask, 30.1 as the default gateway, and DNS server is 20.254. All right. And DHCP was actually successful DHCP. Okay, very interesting stuff over here. And you could look on the command prompt and we'll say IP config space all. Okay, and we expand this and you'll actually see the same thing. 30.1 subnet mask, 30.1 is the default gateway. And you will see 10.2.2.2 as our DHCP server is here. And the DNS server is right here. Okay. And that's it. I mean, we were been able to do that. Now, one more thing, because we are not yet done. We have configured the router as a server. We've configured router R1 and R3 as relay agents. The only thing remaining is to configure R2 as a client. And that's simple enough. And what we are going to do is to get to interface G01, which is the one facing the internet. So we say interface G0/1. You say IP address DHCP. That's it. And then, because I'm going to need you to see how this device is going to acquire its IP address. Once we said IP address DHCP, we need to activate this interface by saying no shutdown. And you press enter. It's not gonna come immediately because the port is just waking up. You can see the port is changing from amber to green. So what I'm going to do, I'm going to fast forward this lab here. And because it's simulation, once I fast forward it, you can see it actually receives the IP address immediately. The interface G001 has been assigned through DHCP. An IP address here, 200.231. The subnet mask is here. And the host name was R2. And it was 231. the one that was assigned. Yeah. Okay. And so, you know, this was very important. And if you say do show IP interface G0/1, and you could see here that it was assigned an address here, 209.231. Subnet mask is here, and it was determined by who? By DHCP. Okay. So that is a very interesting one, and I'm gonna give you guys some work to do on DHCP, and so that you can get more and more of these skills. Later on, we'll be having a combined lab where you configure VLANs, configure inter-VLAN routing, configure DHCP, configure trunking, configure Ether channel, and all that. So please continue gathering these skills because we're gonna put them to use pretty soon. So yeah. So pretty much that marks the end of this meeting. But I can't forget before I give you your assignments here. So please do note down 726 syntax checker, 726 is a good assignment. Then do 7 to 10, then 734, and finally 741, 741, 741. Yeah, 741 is the last assignment. So that's it for today. And the next lecture will talk about DHCP, but for IPv6 with something we call SLAC, stateless address auto configuration. So that is pretty much, I mean, the end of this class, and I'll see you again in our next class. And